Hello everyone, greetings. Welcome to my video tutorial. This is Mitun, and today I'm going to tell about the Proteus and the micro C as software, especially designed for the micro C. So actually, in case of us, actually we need to know actually how to simulate anything in Proteus. So that's why I'm here to teach you actually how to use this. Actually, I'm still learning, so actually what I know I'll be trying to share with you. So here we get started. At first, we're going to tell about the micro C. Actually, this software is used to write the code. This is especially designed for the PIC microcontroller. So if we write the code, and we can use this for the PIC microcontroller. So in case of this, if we open the software, then something will be appeared like this. And so get started. And here you can see the new project. We have to click here and go to the next. Then you have to set a project name so I have written here tutorial, and the project folder you can see here, C user or something like this is having here. So actually project folder is a folder where you will keep your programming. And for the device name here you can see I'm putting PIC 16F777, and according to your wish and according to your need you can use any chip. And for the device clock I'm using 20 megahertz. This is actually the frequency, external frequency for the micro chip. Go to the next, and here you have to click here. Okay, then next, finish. And here we have to make the enable disabled, and okay. So this is the place where we will be writing our code. One advantage can be told here, actually can be mentioned. You know what, in case of micro C we don't need to mention any header file, so that's a big advantage, one of the big advantages I guess. Okay, before writing the code, what do you have to do? You have to plan actually what we are writing the code. We have to plan actually where we are going or what will be happening. Actually according to our need we will writing the code. So it's actually we should work like this. Before writing the code here, what do you have to do? You have to plan first. So for doing this we have to open the datasheet first. So I'm going to open my datasheet here. For PIC 16F777A. So here you can see the chip. In case of microcontroller, actually three things are always cared. So here first thing I can tell about the MCLR or the BPP pin. Actually this is the reset pin. Actually we have to ensure the 5-volt supply in this pin. And for the BDD and BSS, the second thing I'm telling, BDD and BSS. BDD is for the high voltage and BSS for the low voltage. So in case of microcontroller we have to ensure about the 5-volt in case of BDD, and for the BSS we have to ensure the ground. So and for the clock in and clock out you can see two pins here, 13 and 14. In case of this chip, so we have to use the external crystal here. So we know that we have initial is the 20 megahertz, so we will be using this. In case of microcontroller, you know what, there is having the internally 4 hertz the frequency, but in case of actually for the betterment of the microcontroller and for the betterment so that the command can be carried so carefully and so fast, so that's why we have to use any external external crystal. So in case of this we will be using the 20 megahertz. And here you may get confused seeing the BDD and BSS in the both side. You don't need to be frustrated for that. You can use any side of this, so it's not actually bothering. So here you can see the 4 types of pin, like A port and B port here, C port here, and D port here. So you can use according to your need. It's up to you, whatever you want to know, or whatever which pin you want to initialize and which pin you want to use in your project. So in case of us, so we have to plan first. So that's why I'm trying to use RV0. It's not a matter that I'm using RV0, so that's why you have to use RV0 as well. So it's not the case actually. Whatever you want to do here you can do. Just it's your own willing, according to your own willing you can do. So we'll be using the RB0 pin and the RB1 pin. For example, we'll be just executing very little or very small program, so that everything can be understood. So here RB0 will be using as a button. We will press a button and some lights will be lighting, and another button will be here RB1, and if the button is clicked, then the light will stop lighting. And we can initialize many other pins here, so we are not going to do actually I don't want to make the thing complicated, so we'll using only RB0 pin and RB1. So we can initialize here in, okay, I'm now showing you how to use it in the Proteus. This is the component pin, and if you click here, you have to click here in P, and you have to write the zip name. In case of us, there was fix 16 F877A. Sorry, something went wrong. Okay, then we'll be using the redlet. Here you can see the redlet. If you double click on the redlet or the component you want to use, then it will be shown here. So see, you can see it is shown here, the redlet, and they will be using the button. Okay, so we are done. So I'm putting the button here. Okay, I'm putting the LED here, and I told that we are going to use the RB0 port and RB1 port. Then for the power button, you can see here, you can see the ground and the power, so you can use from here. And we have to use power for the button. And we need something else. I told you, in case of microcontroller, we should keep in mind three things. So we are actually, it is for the reset button, and for the frequency we can use here the crystal. It is crystal in case of 13 and 14 pin. Okay, now we have to use the power for the microcontroller. Okay, I can tell one more thing. There is actually simulation. In case of simulation, you don't need to put everything, like you don't need to put power or everything. Just in case of here you can see the microcontroller, and here you can see the I have put the crystal, and here you can see the I have put the MCLR for the reset button. The reset button is here, so you don't need to put those. In simulation, you just can simply do this without even giving the power in the microcontroller. It will be working, so it's not a big deal. But for the knowing, or for the beginner, as beginner, you should know about the three things, and the crystal and the reset button and the power. You should ensure this. So we are not going to, okay, well, we have not put here, so we have to add it here, and we have to initialize a pin here. So we are using RB0 and RB1 as the input pin, and RB2 as output pin. So for initializing, we have to write this way, in this way, B. For the input, we have to actually, how will microcontroller know that we are which pin we are using as input or which pin we are using as output. So in case of this, so we have to ensure this, which pin we will be using as the input, we have to put 1 in case of that pin. So here you can see that I have written the trees b dot f0 is equal 1. That means the b0, here you can see, the b0 pin will be the input pin. That means it will taking the signal from this button, and we using, where is it here, this b dot f1 is equal 1. So here you can see, for the second button, this is from the RB1, so that's also input pin, and for the output pin we are using RB2. So for the output pin we have to write 0. So actually, what will be the initial value of those? Like while we will be simulating, the light should be lighting or the light should be lighting off. So what should be the initial state of the light? So we have to write those in this code. So we have written here the 0 for the port b dot f2, as we don't want to light the light before we pressing the button. Okay, now we have to create a loop here. So we have to give the condition. Actually, if we press the button, then something will happen. If we press another button, then something will happen. Okay, so for doing this sort of thing, we have to use if condition. If port b dot f0 is equal 1, then what will happen? Then port b dot f2 will be 1, and another condition for the another button. If port b dot f1 is equal 1, sorry, then port b dot f2 should be 0. Okay, we just write this in this way according to our ruling. We can increase this, but that's totally up to us actually what we want to see and how we would like to simulate. This is just totally up to us. So we can run the code here. Sorry, we have to put 1 here. Actually, that's a mistake, and the mistake is always good for us to know more. So here, if we put 1, then this loop will be actually continuing. This loop will be continuing. That means it will be working all the time. It will be working. If we put 0 here, then the loop never ever be done. Even the code never ever, this code, within this code, it will never be executed. So here obviously we have to put 1. So we have run this. So it has been done successfully. Now for this simulation, we have to double click on the microchip, then we have to go to the folder, and we have to put the frequency here, as we know that should be the 20 megahertz. Now this is the play button. Now you can see, if you press the button, then you can see the light or lighting, and but it's not stopped. It's continuously lighting, and if we put this button, then this got stopped. So you can see. So again, if we put this, it is now lighting, and if we put this switch, then it's not lighting. So there's a thing. So we have done the code, and we have simulated this in the Proteus. So that's it. And So I'm looking forward from you. If you give good feedback, then I'll be continuing my work, and I'll be continuing in making tutorial like many others, like LCD and many other sensors. And if I can manage, then I'll be showing actually how to work in the lab while I'm using in lab. Then if I make video tutorial in there, actually, then I'll upload in the YouTube. Then you can see there. Okay, so good luck, and thanks for watching.